Okay. Hi, everybody, and welcome to week. I got this week. Week 10, I think. Today's the big week 10. Yes, I'm pretty sure. I think so. I, I told you guys that I would mess this up at some point. But yeah, lots of fun stuff today. I want to start off with a few announcements or just one announcement in particular. How about a few announcements, like two announcements, yeah. Um, so one is that we're going to be having our very special workshop for this quarter. It's the Hollow Knight analysis workshop that we were talking about. Did you not post it in the announcements, Kill? I thought you did. Okay, I
Oh,
think you
I'll,
put it
I'll
on
post
Instagram.
it in a second.
Okay, yeah, but yeah, we're gonna have a really cool Hollow Knight analysis sort of workshop, which is, um, uh, it's gonna be Tan. He's actually in the call right now, which is kind of cool. Tan is gonna be playing through Hollow Knight, the very first area, which is Forgotten Crossroads. Yes, I remember. Um, and I'm gonna just be commentating because Hollow Knight was actually made in Unity, so I kind of know I can kind of like infer how they made a sort of mechanic and what they might have used. So it can be a lot. It'll be a lot of fun. We'll go through like the particle system they use and all that stuff. It'll be really cool. Um, so yeah, that's this. It's next Tuesday. So I think it's 12/5. Next Tuesday, at 4:30 p.m. So like the usual time for the meeting, except it's on Tuesday. We'll still have a regular meeting, so oh my god, my voice. We'll have our regular meeting on Thursday, but we'll also have this workshop on Tuesday if you want to come. It's not mandatory, you don't have to come, but I'd appreciate it. Let me get some water. Got my water bottle here. Okay. My monitor keeps turning off. Okay. Uh oh yeah, and I also wanted to talk about CTI. So CTI is actually like a CS first thing, but I'm a part of CS first also, so I just wanted to like kind of show it here. So if you guys are proficient at coding in general, like you're good at Python or Java, this could be a really good opportunity for volunteer hours. So essentially, what you're going to be doing is later in the second semester, you're going to be teaching kids from elementary school or middle school um, how to code, essentially, right? It's kind of like what we do in CS first. There, Kale posted it. It's kind of what we do in CS first, but like it's um for younger students. So it's a lot of fun. I know I've been a part of CTI for the last 2 years. Um, and it's really cool. It got me like 50 service hours the first year I was there. So like I was just set for the rest of my high school life, you know. So you get a lot of hours from it if you put effort into it, you'll get a lot of hours. Yeah, it's a lot of fun. So you can always sign up with the form we've put in the announcements if you want to. Right, those were all the announcements for today. Let's actually get into what we're going to be doing. So first, I want to start off with um, something a little bit boring, okay? Which is, I talked about all this exciting stuff, and now we're going to some a little bit boring, which is how functions work. So why am I giving you a CS first lesson in game dev? Well, it's because functions are used a lot in game dev. Like it is like one of the biggest things you'll be doing using it in game dev. I need to stream my entire screen, not just this screen. Where'd it go? That was a mistake. Oh, okay. 1 second. There we go. Okay. Now you can see both screens. Yes. Okay. Yeah. So functions are really useful for games because as we all know, we want our games to run really smoothly, right? And we can use functions to allow our game to run more smoothly by reusing like small code snippets so we don't have to type the same piece of code over and over and over again. Yeah. uh Functions, and we'll talk about how functions have parameters, and I'm talking about functions and stuff all today's because we're going to be using some functions today. I just want to clear up any like confusion about functions before we actually get into using them regularly. Oh my god, my voice. All right, I know a function. Me too. Okay, so uh, public. So I made some two variables here: public int num1, num2. You'll see what they do later. Um, let's talk about uh the sort of so all functions all have a sort of data type, right? Um, so and the data this could so the data type is always put right before the name of the function, kind of like a variable. Um, so we have so this is an int type function, so it has to return an int value. So inside these little what are these curly brackets here, you'll see that it returns a number one plus a number two. I'll talk about these in a few seconds. Um, and it'll print out a number. Or it won't print out a number, it'll return a number. The code is kind of small. I can always make it bigger. There we go. That better? I think that's a lot better. good, good point out. Okay. Um, yeah. So it has to return an int. I can make this like a bool. It might give me an error though because this is an int, not a bool. I can make this like a string. So I can make so this is kind of like the data type of the function per se. Like that's kind of scuffed saying like that, but that's kind of what it is, right? Then should we copy this? No, actually, yeah, I was gonna say that. Don't copy this. Don't copy this because it's just like I'm just showing you how functions work. You don't. It's not a part of the. It's not a part of the game whatsoever. Yeah, don't copy it. All right. Int function turns an int value because it's an int function as the int there, and and then that's the name of the function called let's add. And then it has parameters. So what parameters are, they're literally variables inside of the parentheses of a function. And we can actually use these variables inside that function only. Like I can't use number one over here because it's not a part of that function, right? Uh yeah. So I made an int number one, int number two here, and then I returned that integer value of, adding them up because these are both integers. So if I go back up here, into void start. I'm debug.logging. So first I'm calling this function over here. To call the function, it's kind of like f of x, like Tan was talking about earlier. You can get let's add, and then we gotta add our parameters here. So we gotta actually assign the parameter values once we call the function. That's very important. You have to assign your parameter values once you call the function. So for example, see, it's going to be in the same order as well. So let's add has an int number one, which is going to be one, and number two is going to be two. So it's going to be one plus two, which is going to be three. So it's going to be five plus six. That's going to be 11. And then I can actually add variables on top of variables. So I can make num1, num2, what these numbers are. And I can actually change that inside of Unity itself. Pretty cool stuff. I notice how I have to print all this stuff, like because it just gives me the value, but it doesn't actually print out the value in the console, which is what I wanted to do. So if you go back into Unity, you'll see I put like some bigger numbers in here, and when I run the code, when you put my console, when I run the code, it's not gonna do anything on the screen because I didn't put anything on the screen, but it's gonna print out all these numbers. How nice. Cool. Let's talk about void functions. So void functions are just functions, uh the data type is void, which doesn't really make sense, right? Because like it's void, that means it's nothing, right? Yeah, it doesn't have to return anything specific, which is actually really useful. Because what if you don't want to return a data type after you make a function like that? That just doesn't make any sense. And what if you want to just use it as like a reusable code thing, like I was talking about earlier, so you can reuse the code over and over again. Like if I had like a um, what's a good example? Oh, I have a good example later on today, but I can't really talk about that right now, can I? Um, but let's say I had like 100 lines here, and then what? Let's say um, what's a good example of a function? I should have thought of this. Uh, okay, let's say I have a bunch of car parts here that need assigning, and I'm assigning them through by making them like sort of variables like the tire pressure or the color of paint, and they're all like parameters here. And I want to reuse that over and over again. I can just call this again, and instead of making it like 5 lines each time, it's gonna be 1 line. And when you're doing that like 100 billion times, it's gonna get like it's gonna get a lot. It kind of stacks, and it stacks well because then you save a lot of space by just saving just using it once will save one space. So I'm only using it 3 times here, which might not look like much since there's only really 1 line of code in here, so it's kind of just the same, honestly. But if they had like 100 lines of code in here and I reused them, that saved like 300 lines of code. Like that's a lot of code, a lot of space we just saved. So you kind of get why we're doing that, right? Let's go back to voids. So void functions, they don't have to return anything specific. So I can literally just put the debug.log in here and it'll be all good. And to demonstrate that, I'm just gonna remove the comments here of this, and then I'm gonna comment this up. Paragraph. Okay. Save that. Then when I run it, it's gonna do the exact same thing. I'm pretty sure. Uh, if it loads, that is okay. There we go. Should print the exact same thing. Yeah, I think it did that. Yeah. So it printed the exact same thing. It didn't look like nothing. It looked like nothing happened, but it did happen. Trust. It happened. It happened. Look, I'll clear it and then I'll play it. Then it'll work. Show up. There we go. See now you can see it working, right? So that's how functions. That's the really basics of how functions work. Does that make sense? So I won't be going back to this anytime soon. So just ask any questions right now. If you have any, like, you know, how do you call a function? You call it by just saying its name in the parentheses, and if it has parameters, you put parameters. You don't have to add. You don't have to have parameters in functions like void start and void update. They don't have parameters, even though they're functions. So yeah, make sense, everybody? Yes. What is return? It just returns a value. So like it just like out it just spits out a value essentially. So here it's going to spit out an int value because it's spitting because it's an int. So and we're adding these two numbers. These are both ints. We'll spit out that value. Okay. Any other questions? I literally didn't talk in school like the whole day just so I could like speak today. Um, is start continued a function because it has void behind it? Yes, start the void start and void update, they're both functions. They're both functions, yeah. If that wasn't already apparent, but yeah, they're both functions. That's what they do. They're just special functions, right? They already do something predetermined by Unity. So you can't really name another thing void start. Yeah, Kanishk? Kanishk? Damn it, I forgot. Is it Kanishk? It's Kanishk, right? Kanishk.
I'm pretty sure it's Kanishk.
Yeah, Kanishk. Why is everything we do inside a class? So this class is essentially like this is what makes up the all right. This is gonna be a different conversation. Okay, I'll yeah, okay, sure. So in this class we have functions which is derived from mono behavior. I think I talked about it on the first day. I'm not actually sure, but I'll go over it again if I have to. Mono behavior essentially kind of gives us all these special Unity type functions uh like public rigid body, all that stuff. So along with the using Unity engine allows us to use mono behavior, which allows us to add those rigid body 2Ds and stuff like that. But we can make stuff outside of the class, but they'll have their own purposes. Yeah, object-oriented programming. That's a CS first topic. Yeah, we don't have to get that too much in depth here, okay? But yeah, just put everything inside the class, okay? That's what I'm saying, because everything derives from the mono behavior. One behavior has one function. I don't think there's a duo behavior, but I could be wrong. All right, let me load up the actual project we're doing today. That was just a little mini thing. That took a lot longer than I thought it was gonna take. It's okay. Also, you do know object oriented programming, so you kind of understand the concept then, right? Oop. Where did it go? Here. Adrian knows all about object oriented. Well, Adrian, why don't you tell them about object oriented programming while I get this loaded up? CS first instructor, you got this.
Hey Ryan, there's something wrong with my Unity. I'm trying to figure it out right now, but just go by yourself for now, I think, until I get this figured out.
Oh, okay.
Yeah, sorry.
That might be a bit hard to split it up then later on.
That's fine. I mean, there's nothing I can do about that.
Damn, okay.
Yeah, sorry about that.
No, it's okay. What was I saying? Oh yeah. So let's get back to our runner game, shall we? Let me run this. So last time we should have finished the basic jump without any of the squashing stretch. Let's see if it works. Oh yeah, it works. There we go. Look at the little guy. Yeah. One thing I forgot to mention last time is that I forgot to mention that we actually coded this in, but like I didn't like explain it. For some reason I just typed it out and I gave explanation. I was talking about something else at the time and I didn't explain this part, but we also added it so that if you hold down the jump button, you actually jump higher. So if you just tap the jump button, you jump lower, but if you hold it down, you jump higher. Kind of like Hollow Knight, which we're gonna cover. So you kind of know how Hollow Knight made its jump now. Pretty pretty cool, right? Yeah, I think that's essentially Hollow Knight made its jump. Yeah, I forgot to mention that little mechanic. All right, let me. All right, so what we're going to be doing now is we're actually going to be making the squash and stretch, and we're also going to be making the enemy today. And with that comes a little confession. All right, so strap in. So I gotta complain about something. All right. The game we're making now is actually a game I've made before in 48 hours for a game jam. I want to show you guys this. So the game we're actually making right now is sort of like a mini clone of a game I made a few years ago for a game jam. And that game was called Stress. Let me show you guys what Stress was. Here's Stress. Yes, made for the Cultivation Jam. Why the Cultivation Jam? I couldn't tell you. I just picked a random jam. Yeah, Stress. Stress was it was super fun to make. It got some crazy good art from Tan. Uh, it was really fun. The music slaps. Uh, I recommend you play it. It is a little bit confusing to learn though. Here, I put it in the chat. But yeah. So, thing about Stress is that it's almost identical to what we're making now. Let me just show you what it looks like. And this will actually give you a good idea of what we're going to be continuing to make. Oh, the sound is on. I'm muting that. The sound slaps, but like, no, not the digital circ. That's crazy. Okay, I was original. I was original. I made it first. I made it before Digital Circus. Okay. All right, tutorial is really cool. There's some jokes in here. I don't need a tutorial though. I made the game. Okay. Can you see it well though? I think you can see it all right. Start. It has a cool cutscene and everything. I'm actually kind of proud of this game. Yeah. And so you kind of see here, uh, essentially what we made together. Yes. So there's all these types of enemies and all these really cool stuff. It's essentially what we're making right now. That's what we're gonna be making. That's what I based this off of. And today we're gonna be making the Eraser enemy, which is gonna be a lot of fun. It's not going to be as elaborate as this one because we don't have a shooting mechanic, or we don't have a duck mechanic, but it'll still be pretty fun to play. You'll also see that there's a lot of other enemy types, and I'll talk about those other enemy types. Um, maybe next meeting or maybe a bit later, but yeah. Right now, focus on the eraser. Oh, I died. I like the. I'm especially proud of this, like, where you die. I feel like it's really organic how you die, how you get to the death screen. But yeah, today we're gonna be making the eraser mechanic. Very cool. Yes. Okay. I need to stop playing my own game. I drew the cover art for Stress outside of the USA in a bathtub. Oh yeah, you're in Taiwan, right? Or was it quarantine? I don't remember. I don't think it was quarantine though. Oh, when you need to go to Taiwan, you need to quarantine. Oh, I get it. Okay. All right. We could in a bathtub. Yeah, that was crazy because it was actually a week game jam, actually, if I remember. It wasn't a 48-hour one. I usually do 48-hour game jams, but this was a week game jam. Yeah, yeah. I remember now. Yeah, that was actually made in a week, not 48 hours. Why is Roblox in your quick find? That's KL's fault. You can ask KL. Okay, that's all KL's fault. KL, that's your fault. Okay, you got me addicted to find everything.
What did I do?
Okay, wait. We gotta actually code. We're getting off topic. Yeah, I spent all nighters on that week. That week was like hell for me, but I like the end product. Okay. Oh, good times, good times. Okay, we gotta um actually do this today now. Okay, open up your player jump script. Nice. My Visual Studio stop respond. What the? Okay, it crashed. Great. Oh no, it didn't crash. Okay, it just I don't know why it said that then. Okay, it's fine. It's saved. Okay. So it should look like this right now. All good and stuff. Um, let me just open something up real quick. Yeah. So we're actually gonna be creating the squash and stretch um inside of the code. And the reason why we do that, why we're going to do that, is because let's see what happens when I try to add the squash and stretch on the player jump now. So I'm gonna go my player. I'm squashing a little bit. Stupid fan. I'm gonna squash him a little bit, stretch him up, uh, and then maybe I'll squash him back down with the last frame. Yeah, so that kind of looks like what it will look like, but this should only happen once. But what's going to happen is it's gonna keep looping because our jump is on a loop, right? So when we jump, it's gonna keep squashing and stretching up, which I mean, that doesn't really look like it. Like the whole point of squash and stretch is to have more emphasis of physicality, but it's actually giving us less physicality right now. Don't like that. So we're actually gonna do this through code, which is actually gonna be a lot more easier than doing it through. Oh, what did I do here? Oh, I removed the sprites. Okay, there. What the heck? Where'd the middle sprite go? Oh no, I did something. I broke the animation. Okay, wait. Let me find the missing sprite. I think it was this one. This one I'm missing. Uh, Great. See what happens when you try to do it with scale. What is happening? Okay, that does not look right. Uh, I've moment. I love that frame. What is happening? Oh my god, something went horribly wrong. Okay, where is it? What? What happened to the? What the heck is happening? Oh, here. Okay, that looks better now. Okay, I had to like lock in for a second. Okay, wait, let's go back here now. Spam Control Z until your keyboard cracks. That might remove actual progress. Okay, let's actually make these variables now. So we're gonna be making these scale through the script. That's what we're gonna be doing. That's what I was trying to get to. Okay, right. Let's make some variables, shall we? All right. So first, let's make a public float scale x and a public float scale y, so we can edit both of the scales. Oh, that is not public scale y. There we go. Um, I'm gonna make them both equal to 1 to start because if you see in our scene, the player's scale is already set to 1, so already kind of makes sense, right? Cool. Then, um, yeah. Then we're going to be going down here, and we're gonna be making a function. Wow, it's like I just covered that. But it's actually going to be a special type of function that Unity made specifically for, making timers, and that's called IE numerators. What a wacky name, IE numerator. I don't know why they named it that. But now we see. They're called IE numerators. So there's going to be a special return we have to do for an IE numerator. You're going to see it in a second. Yeah, but first let's add our parameters. So first let's get our float scale x start end and our float scale y end. So it's gonna so basically we're gonna be tracking what the end of our um what the end uh of our squash and stretch is gonna look like. What will it look out what will it look like fully stretched out? That's what we're doing here. What we're gonna assign with these parameters. And the float time, like how long is it gonna take for it to get to that squash position? All right. Yeah. Um, I have to check something. Just 1 second, guys. I'm sorry. I'll be back in 3 seconds. Okay, I'm back. Set a check on something. 1 second. Let me get this open. All right. What was I doing? Yes, coding. Let's get back to that. About the screen. Can you guys see the screen? Yeah? Okay. Let's finish up this IE numerator. Here we go. All right. So let's first get out the scale x. Let's make scale x equal to the scale end. So scale x start with it. There we go. I can make it auto-complete it for me. I don't have to actually type it all out, right? There we go. Make those equal to those. So that like when we assign these in the parameters, we're gonna assign like the most stretched out values. So the current scale x is actually gonna become that scale. Oh yeah, I totally forgot. We should probably do that. Okay, wait. Let's go back to the update for 1 second. That's what I was missing. Okay. Yeah, I knew I was missing something. Okay. Um. Yeah. Before we do all this, we gotta make it so that the transform scale, which is the local scale, a transform's local scale is actually equal to whoops. It's actually equal to the scale x and the scale y at a constant pace, right? We always want it to be equal to the scale x and the scale y. There we go. Okay. Yeah. Yeah. So we want to do that first. I totally forgot about that. We want to do that first because we always want the update function. We always wanted to we constantly always want the scale to be equal to these scales so that when we change it in this function, uh, then we're gonna then it's gonna be changing it constantly to this, and then it's gonna be, once you change it back, it's gonna constantly change it back to that. So it's gonna keep going and going and going every single frame, and it'll constantly be whatever we change these variables to the current scale. And he made it a vector 3 because if you look over, not there, if you look here, um, the scale is a vector 3. So we need to make it a vector 3. It has 3 values, scale x, scale y, scale z. So what this does, let me just reiterate. What it does is it just makes the scale equal to what these variables are at all times for every single frame. Yes, okay. Let's get back to working on this script. Okay, so now we're going to talk about that special return that the IE enumerator uses to get its time. So once we make them all stretched out, that's what it does. Let me just make a comment there. Stretch it out. Now we're going to set up wait for a little. So we're going to make it wait for a little bit, and then we're going to turn it back, so that it actually looks like it's kind of like stretching up and then going back to it. And the way we do that is we have a really long line that makes us type. It's yield return new wait for seconds. And we're going to put the time variable in there so we can change it on the fly when we're making the parameter. So we're waiting for a new wait for seconds. Funny. So the I enumerator returns a wait for seconds. That's essentially what it's returning here. That's what we were talking about before. So after it waits for that time, we're gonna revert the scale back to 1. And remember, this is the current scale right now. Remember, because we made these the variables. So save that. Turn back. It's always good to comment your code. Usually, if you're working in like a company or something, like when I work in my internship and I have to code something, they always want me to comment my code so they know exactly what I typed. Right? What's yield? So yield return is actually a full statement itself. And we just use yield return for all the sort of time functions. Not time function, that's weird. Okay, we use it for all the wait for functions. That's just like a rule in Unity. You understand, Adrian? All right, we need to get back to this. Then return it to 1. Okay, yeah. So it's always good to comment your code when you can. Yeah. Because this looks kind of confusing when you don't know what it does, right? Need some water. Okay. 1 second. Oh, that's a lot better. Okay. Let's go to our jump, and we're actually going to be calling this I enumerator at our jump. And I enumerators, like, this is kind of a weird function to start off like making functions, even though we kind of did already make a function, but we don't talk about that. But this is kind of a weird function to start off learning functions with because it's actually a unique function. We have to actually start it off with a certain command. That's start coroutine. Coroutines are kind of just like timers. Just think of coroutine as timers. Like it could be replaced start timer. And then You just start the coroutine and we do bouncy. You don't do this for any other thing. Or iNumerator is just kind of special like that. Quarantine. You know what's so funny? I started using Unity in quarantine. So I was like, I kept saying quarantine when ever used quarantine. It was like, oh, I can use the quarantine to stop time? That's crazy. What is happening here? Oh yeah, I need to add the parameters. Totally forgot. Uh, See, that's why you got to learn how to use functions. Otherwise, you're not gonna know what's wrong. Yeah, I have to add all these parameters here, right? I have to add 3 parameters. So to get these parameter values, let's actually go back and let's like look at our player and see what are some stretch values that the player would look good in. I'm gonna go back here. Let's look at our player. I'm gonna stretch him a bit. That's pretty good, I think. I think that's pretty good. I'm gonna use these values. So just take these values. You can make it whatever scale you want it to change to. It's always gonna change back to 1 anyway. So I'll make it for 0.625. That's the scale X. Let's get our scale Y. It's 1.6125. Oh, make sure to make these floats, by the way. So put the F next to it. Because otherwise you'll make it in double and they'll just be a little bit bigger for no reason. And then we can put the time. I'll put like 0.25. No, 0.2 seconds. I think that's actually a good value. So it's really quickly gonna happen. And make sure that this start coroutine thing is inside of when you click um the W button, not when you let go of it. Otherwise it's gonna look kind of weird. And once we play this, it should look fantastic. Take a little bit to load. Okay, let's run it. Oh, it kind of started. I gotta stop this. Wait. Stop the train. I gotta make this back to 1. How does this look? He's vanished. Fantastic. Okay, where did he go? Did I not? I set the values for this. It should be. New vector 3, scale 1. Maybe I'll set these inside of the start function. Maybe that might make it better. More apparent. Okay, save that. Okay, now it didn't disappear. Oh, it works. Look at that. I do think it's stretching a little bit too much, so I'm gonna make it a little bit less stretch on the x-axis. So I'm thinking like 0.4 or no, I mean the y-axis. The y-axis seems a bit too stretched, so I'll make it like 1 point. How'd that look? You can always set whatever the stretch value you want it to be. You can make it like crazy if you want to, like super stretchy, but don't make it like really like way too stretchy so it looks like don't make him like a monster every time he jumps. That'd be kind of weird. Like you make him like Godzilla every for like 0.2 seconds. I want to make it believable. So I think that's actually pretty good. That looks pretty awesome, right? It looks a lot more fluid, a lot more emphasized, the jump. So you gotta see how cool Squash and Stretch is, how much better it looks now. Let's see what it looked like before Squash and Stretch. So I can just do that by commenting this code out. Save that. If you have an error with this, just tell me right now. We'll go over it. If you do have an error with it, just comment the code for now, and I'll go over it with you after because I really want to cover a little bit of enemy stuff today. Yes, Squash and Stretch. Oh, you need to add commas in between each number. Yeah, see, this looks really static and really bland, right? Compared to that before. So I feel like we did a good job there. Looks a lot more fluid. Woo! Good, nice, Carson. Looks great. Yeah. Make sure I add the commas. Because because it's a vector. It's no, it's not a. What are they saying? No, that's stupid. Okay, why did I say? Why did I almost say that? Yeah, no, it's because we separate these by commas here, right? So it's like assigning the same values from here to here. So you gotta add the commas. Yeah, this Olympic skater's got great squash and stretch. Look how his body like splays out once he lands on the floor. Can't really do any of the stuff he's doing right now. Yeah, you should probably watch those videos then. Yeah, but now that we got all the squad, so basically we got the player controller working. Yay, that's great. Now let's work on the enemies so the player can actually dodge some stuff. Cool. We have like 15 minutes, so we'll get like the really basics done, but yeah. Play last week's VODs on 2 times speed. I actually recommend that. I think that'd actually be good because sometimes I kind of sometimes I kind of just like keep talking about the same thing over and over and over again because I'm stupid, but uh yeah, maybe 2 times speed might be a good option, honestly. So if you go to the files channel over here, I'm streaming right now. The files channel, you'll see I posted a little guide for today, the eraser guy from Stress. So you can go over there, click him, copy, and then right click him, then save the image, just like we did with all these other sprites. And then put him into the game. So I'm gonna do that too actually right now. So here, save the image. Then we go back into Unity. And then we can play our fun compression game, right? What do we save it as? Anything. It could be anything. Just make sure you can remember where it is. That's the most important. You can just name it Eraser. It's also the moving platform from Eagle Quest last year. So I've used this. I've used this Eraser sprite like 3 times in 3 different games. Crazy. Very resourceful as a game dev, right? Okay. All right. Who should I pick for the lucky compression guy today? Let's see. What about who haven't I picked before? Dylan, did I pick you before, Dylan, for compression?
Compression?
The compression. No. All right, let's go through it. So, do you remember how we compress sprites in Unity?
Okay. I don't even have my like eraser imported yet, so I
Oh,
can't
okay.
even start.
But you can look at my
Let
stream
me.
and see me do it, right?
Yeah.
All right. So, what's the first step?
Um, the pixels per unit, you could put it
Exactly.
to
Whatever this is.
um
What is this? This is
30.
30. Yeah. So let's make it 30. It has to be all the same pixels per unit. Then what do we do?
Um, you put the filter mode to point, no filter.
Perfect. Then what do you do?
Go to max size. You probably put it at 128.
Yeah, good job. Right above 70, but not 64 because then it'll be all crunchy. Then what do we do?
Uh, shoot. Okay.
One last one. You got this.
Mm, oh yeah. Go to compression
Uh-huh.
and put it to none.
Yeah, there we go. Because you already compressed it enough. You don't need more compression on our pixels. Oh my god. Peter Piker, pick up pen, bro. I messed up both of those. Good job, Dylan. Good job. All right. Yeah, so we got it all. I stopped streaming for some reason. I got so embarrassed. Great. Um all right. We got our razor in. I'll rename this because it's good to rename stuff. I always forget to rename an object. It's always just image 31567. Uh, so like yeah, name it something. Definitely name it something. You want to name it something. Let's see our razor in here. Very nice, nice boy. Make the order and layer a little bit up just for fun. You don't have to do this right now. So let's make an enemy spawner in quotation marks because we're actually going to be playing another trick on the player. 10 minutes, okay, that's okay. Um, and we're gonna make a trick on the player. We're actually gonna be keeping all of the enemies on this right side of the screen at all times and just like putting them outside when they need to be. And the way we're gonna be doing that is we're gonna be using a state machine, which is just the animator, but we're gonna be using it in like a non-animator fashion. It'll be really funny. You'll see. Um, So it'll kind of look like all the if you look outside of the current camera scene, it'll look like all the enemies are just waiting to attack the guy, but really it's only one at once. So okay, let's make the Z at 0 first of all. That's very important. Let's move this back over here. Omit the enemy spawner in quotation marks because it doesn't really spawn stuff. It just kind of puts it out there. Put the eraser here. Let me just capitalize the eraser because it's and put eraser as the child of enemy spawn. The child. So now eraser moves with the enemy spawner. Cool. Then I'm gonna flip the eraser on the x-axis so that it faces the little bird guy. Yeah. And then let's make some animations for the eraser. So click on the enemy spawner. Quick question: how do you make the scene smaller? Right now, my entire bird screen's taken up with the bird. You use the scroll wheel on your mouse with the touchpad to just like move it, right? Is that what you mean? Yeah, yeah. Okay. Yeah, just use your trackpad or the funny mouse wheel. Yeah. Cool. Okay. So I like to zoom it out a little bit more because it's going to take up the entire screen. So you remember earlier in the stress demo, not demo. That's the full game. In the stress thing, I was showing you how the erasers a move is just to move across the entire screen. We're gonna be doing that right now. So let's click on the enemy spawner. It has to be enemy spawner. Don't click on anything else. Click on the enemy spawner. Okay, the parent game object, and make the animator on that. So I'm gonna make the first thing. I'm gonna call it eraser down attack. So there's going to be 3 attacks. It's going to be a razor middle attack, a razor top attack, and a razor down attack. Okay. So here's a razor down attack. How do you make an animation again? If you don't have the animation window open, just go to window and then open up animation, and then you can make. And when you click on an enemy spawner, you'll see a button over here. Yeah. Okay. Let's make this cool eraser sweeping motion. Yeah. So I'm gonna start my keyframe here. I'm gonna move it like, let's say a second for now, and I'll zip him to the other side of the screen. So there's one keyframe at the start and one keyframe at the end, and then when you move it, it's gonna look like he's moving across the screen. Meow. Okay, that's okay. Maybe a bit faster. I want to be a bit faster. Now that looks like a real threat. Right? Airplane noises. um, this is good for now. Let's not add any flashy effects. I added a flashy effect in stress where like a whole like white eraser sort of like line, kind of like a gaster blaster will go across the screen, but we don't really need that right now. A trail, yeah. We don't need the trail for now. No way, Sans Undertale? That's crazy. That's flashy. We can make it more flashy. It was like the chalkboard. The chalkboard was pretty cool. That was actually the last thing I made. The screen throws numbers. 10, no, 10 is joking there, Kunal. 10. He is definitely, bro. You have no idea. No, don't feed him. He's an Undertale savant. Don't do it. Don't. Okay. Okay, so we made the Razor down attack. What time is it? Ooh, 5 minutes. Okay. Punchy. We'll make the Eraser middle attack, which is essentially the same thing, but we're gonna move the Eraser up a bit to start, and then we're going to. What was it? 45. Yeah, 45. So move that here to the very end. There we go. We got a middle one. I just didn't have Razor for some reason. Let me go back here. You can go back to the animation files and rename them. And remember, animation files aren't animation states. They're two separate things. So we have to go back to the engine spawner and then rename this too. Middle. So just to say that again, I accidentally oh my god, my voice. I accidentally named it just Razor, but I wanted to raise it. I wanted to name it a Razor middle attack, so I renamed it here in the animator and the file. I renamed both of them because the state is not the motion, like how we talked about like 2 weeks ago, right? All right, and then we'll make our Razor up attack. How creative. Up. So now he's up. Go to 45. Move him to the end. And maybe I'll move him down. So how about here? That looks good. Okay, that looks better. 2.81. Cool. All right, so we got an up, we got a middle, and we got a down. And funnily enough, the down is at the top and the up is at the bottom in the preview. Whatever. Cool. So we got all our attacks. We don't have time to code it today, sadly. The code is really interesting, and I have a really funny story to go with it. But that's for next week. Yep. So we did a lot of progress today, right? Fun stuff. Those of you who still have an error with the squash and stretch, you can just tell me, and we'll talk about it after the meeting, which is in 2 minutes. But yeah, remember, we have a workshop next Tuesday. And you can sign up for CTI if you want to. And we also have a meeting on Tuesday and Thursday. But the Tuesday meeting is just a workshop, so you don't have to go. Okay. All right, it'll be a lot of fun though, so I recommend it. But yeah, but you should come. You should come. It's a lot of fun. But if you do have something to do, then you don't have to. But you should come. All right. Yep. I'll see you guys next week. Bye.